Hi guys, this is my concurrency lab. Starting here in the producer class, I used a for loop to iterate through the number of items to produce variable. So right up here, um, each loop tries to create a new item and uh, sends it to the warehouse using the .receive method. If that fails, it uses a catch just to print out an exception error. Uh, Over my consumers, pretty much the same thing. Another for loop to call the warehouse.ship method. If that fails, the catch block prints out an out of stock exception and interrupts the current thread and breaks the loop. So I'm not sure. I saw people using this online and stuff, so that's why I put this in here. I'm not sure if I need it. Oh, but I think it helps break out. I'm not entirely sure exactly, but I think it helps um, with just management here of the threads. My warehouse class is slightly modified. I use synchronized inside my methods here. Um, so all the methods of the get number of items, receive, and ship have synchronized instead of synchronization blocks. I think this makes the warehouse instances more versatile, and it would allow me to have multiple warehouses of on different threads, I guess. So from what I can tell, this would let me have like I could have like four warehouses running at the same time, and they wouldn't be uh, like running into each other, just because I guess of the array list is an instance variable. Um, if it was, I guess, inside each method, then I would have I would have to change it up and use a synchronization block from what I can tell. Um, so my first method just returns this array list size. My receive method just uses the dot add from the array list, adds the item that we get from producer to the first element of the list, and that effectively pushes back uh, the the rest of the list. Third method checks if storage list is empty. If it is, it throws an out of stock exception. If not, it returns storage.remove, um, which is the first element of in this case, yeah, using the first element of the list. Um, Moving into my sequence diagram, I've never like created one of these before, so I hope I set it up properly. Uh, Here is our test threader class that the professor gave us. It creates instances of our warehouse, of our producer, and our consumer classes. It passes variables to the producer and consumer for like how many consumers, how many producers, how many items they need to create or consume. Uh, then these are the try methods I have here, just showing that it tries, and then if that succeeds, it's going to um, do the dot receive. For consumer, it is doing the dot ship here um, to the warehouse, basically. I think I'm actually missing down here the catch part. I think I have to add catch down here to show for both the consumer and the producer that it does an exception if that fails. But uh, I think I messed it up there. But also I have this alternative like thing here. So it's checking if it's not empty. If it is empty, just showing that, hey, if it's not empty, ship it. If it is empty, you go into an exception again as well. Um, I think, let's see here. I think my answering the questions the professor had, I think my code is mostly thread safe because I use the synchronized methods to stop race conditions from occurring. Um, this same instances though of the variables, sorry, of the warehouse. So I think that's something slightly different. I think than what I saw a couple of the other students using. Um, as far as what's going faster and slower, the concurrency tests originally were running slower by like about a half a second than my sequential tests. That's most likely due to um, the synchronization process. From what I can tell, takes CPU power, and then also using the creation, it was creating 10,000 threads in this case. My CPU is only 12 threads, 6 cores. So from what I can tell, there's a lot of overhead that goes on into it if I go above my thread count. So it wouldn't be as efficient, I guess, for in here in the integer's number of consumers, it was 10,000 if I remember correctly, and then there was 10 items per consumer. So I changed it up actually. I made it both the same down here, so consuming sequentially and consuming concurrently. I made it 12 consumers instead, and 60,000. Oh, okay. So this one's slightly off. I messed that one up, but it was 100,000 originally. So yeah, 100,000 items that we need consumed. And the sequential one took about 2 minutes. I want to say it was 2 minutes and 15 seconds or something like that. Um, a lot of that is the producer here. You can see it's going through. I think we only have the one producer trying to do everything, and it takes a while to go through 10,000. Sorry, 100,000 items. So uh, when I was doing the testing, I noticed that as my threads were low, and the number of items produced was really high, or sorry, number of items consumed was really high, like above 50,000. Um, then sequential and concurrent were getting closer and closer, and I think at 60,000, concurrently was slightly faster by like a couple seconds, or maybe even it was less than that, but it was slightly faster than sequentiality, uh, sequ- than the sequential, I guess, test. So again, I think that's mostly just due to how it's setting up here. So you can see it going through each. It's doing the main thread, and it's going one consumer's ending, the next one's starting, and it's just gonna go down and do all 12 of them. So it is quite slow for 100,000 items. But when I was doing the tests with all 12 threads running at the same time, it took a second to start them all up, and then it would all end quickly. So it felt faster. And it was saying that it was a little faster for the 60,000. So I'm curious here in the 100,000 if it will be significantly faster, or if it will still be around the same time. Performance to the code, I think I saw that a thread pool system would be a good way to reduce like the overhead. Um, I also think that a better thread safety method would increase performance. So I'm just using synchronized in the methods here. I think I saw that if you want like the best performance, you should do synchronized blocks. In our case, my methods are really simple, so they don't really. I don't think it's a huge difference. But I think if my methods were more complex and there was things that I wanted synchronized and things I didn't need synchronized, that's where I would really want my my stuff to be not the whole method synchronized. I think Tim did it where it's just blocks, and I think that's more efficient. So we're going through the producer now for the concurrently. You can see here it took 2 minutes and 23 seconds for the sequential test. So hopefully, as you can see, the producer takes probably about half the time of the entire test. Just because I don't think it's not set up properly for 100,000 items. So just waiting on it now. I'm gonna pause. Okay, it's working again now. So we're at consumer 0, consumer 6. It's a little strange that and it's set up like this. I'm not sure. I'm guessing, yeah, they just kind of get their names randomly, and I guess they all pop up at the same time. So I'm guessing some of them are slightly faster. My thread, I don't know if that is like my CPU or my code here that's doing that. But yeah, they're not in order in this case, but you can see that they're on the different threads supposedly. Still waiting on them to start finishing, so I'll pause it again. And we're done. So actually, interestingly enough, they turned out to be the exact same amount of time. From what I can tell, it doesn't really tell me the milliseconds here. Maybe I'm missing something, but yeah, they ended up being the exact same amount of time to finish both processes. Consumer 0 ended actually like a good 5-6 seconds before the rest of them all ended. All of this, they all basically ended at the same time except for Consumer 0. So I'm not sure what that's about. But yeah, that's my code. Anyways, thank you so much.